Okay, good morning. Can you hear me? Just want to check.
Yes, doctor.
Okay. Um, okay, so is the slide available? So can you see? Is it moving? Is it moving?
Yes, yes.
Okay. Thank you. So very good morning. So I'm Dr. Ellen. So I'll be teaching the subject. Okay, EMJ26402, Principles of Thermofluids. Okay, which will be carrying out throughout the semester with 3 credit hours. Okay. Okay, please hold on. Okay, so I will just give some overview of the subject and how we're going to carry it out throughout this 14 weeks. And we will start with some introduction. Okay, so we will move with. Is there any questions in the chat? Okay, no. Okay, so for the course outline, okay, so I will give some synopsis, timetable, and myself as the lecturer, and also the course outcome, assessment, references, and also I will present the teaching plan. Okay, as a synopsis, this course covers the fundamentals of fluid mechanics, thermodynamics, heat transfer. Okay, actually, heat transfer is not really in the syllabus, but we will be covering because you cannot uh, escape from the heat transfer. So we will cover a little, but we will cover we will not cover the fundamentals of it. Okay, and we also other applications in the engineering field. So thermodynamics focuses on the fundamental principle of thermodynamics and is general analysis. Oh, okay. So for this subject, we will have some calculations that you need to master into, and basically, we will see on the principles, okay, or the theory part of whatever things that is happening in the thermodynamics. Okay, so that's why it's stated here. So it will have a general analysis. So meaning we will give a problem, and you need to find out how to solve and get the calculation done. Okay, and we will cover the fluid mechanics part. So attention will be given to the fundamental principle of fluid mechanics. So fluid mechanics meaning the movements of the fluid, okay, whether it's in the static form or in the dynamic form. So it will carry some fundamentals, okay, and we will have the fluid statics and fluid dynamic, so which will be covered as well. Okay, so okay, this semester we have some issues with the timetable, so I'm not sure what is the reason, but seem like based on the poll that you have answered, so all the slots are having clash with other subjects. Okay, so there are, we have 4 slots actually. So slot one, so which will be on Monday, so 10 to 12 p.m. Tuesday, 8 to 10 a.m. Then Thursday we have 1 hour slot, so which is 4 to 5, and also Friday, 10 to 12. Okay, so which we are covering today. So since today is the introduction, so we will just cover 1 hour. Okay, so we need to come to an agreement because if not, you cannot really attend. So this subject, I need to tell you, is better for you to study face to face. Okay, so I don't really prefer the online approach for this subject because it will have a lot of calculations and derivations, which uh, when we are studying online, so you will have a lot of limitations because we don't have whiteboard, we cannot write it freely, and everything we need to put it in a slide, so which can be troublesome. And as a student, I believe you also will have struggle to understand. So we need to come to agreement. So either we do, I just carry out with the face-to-face class. Okay, whichever slot that. So I think Friday slot is only 11% saying cannot. So I just give the 11 people some flexibility to listen to the recording and come. So, but if you are listening to a recording, then I need to assess whether you are listening or not. So there can be some kind like a assessment lah. If you are listening online, so if you are attending face to face, it will be okay. So I will take attendance based on that. Okay, so we will discuss on this after the overview. Which slot we going to take, because our subject is only 2 hours lecture subject. We don't have any lab, so it's fully on class mode. So we can use either one. Uh, so if we can come to agreement, any of the 2 hour slot, then it will be good. If not, we need to go for 1 hour face to face, 1 hour online. So something like that. So that's what I am thinking of. But it's okay. So to this for this week, we will do online. Um, okay, so the subject will be fully. Uh, I'll be teaching. Okay, so my lecture room is room number 72 in the FKT1 building, the light blue building. So my office is there. But at times I'll be in another research room. So most of the time I won't be in the blue building. So if you have anything that you requires any meeting or what, please contact me and set appointment first. Okay, so the consultation hour will be from 8 a.m. until 5 p.m. during the working hours. So please don't contact me after the working hours. Okay, so I already told this so many times to the other batches also, but I always will receive uh, WhatsApps or call late at night. So please cooperate. So just make sure you just keep the contact time between 8 to 5. Okay, unless it's very urgent matter that you really need to contact me, then it's okay. So if not, please stick within the time. Okay, so that's what I want to tell. So even if you contact after the working hours, I will only reply the next day. Okay, so we just come to agreement on that. Okay, or you can even contact me through via email. Okay, so this is my email address. Okay. Okay, so course outcome for this subject. Okay, so we have two course outcomes. Okay, so course outcomes are the outcomes that we need to achieve at the end of the course. So we normally will give you the Google form for you to fill. So to evaluate the lecture and also the course and also the lecturer. So we will calculate the course outcome achievement at the end of the semester and what are the things that we need to improve. Okay, for this subject, we have two course outcomes, CO1 and also CO2. Okay, the first course outcome is ability to apply the basic law and principle of thermodynamics and fluid mechanics. Okay, so this subject is covered to two parts. The first part we will be covering on the thermodynamics. Okay, so it will be around 5 chapters, and the remaining 4 chapters we will cover the fluid mechanics. Okay, so we want to learn how to apply basic laws and principle in these two parts. Okay, and course outcome two is ability to analyze theoretical concept of thermodynamics and fluid mechanics in specific application. Okay, so thermodynamics and fluid mechanics cover very large applications. So we will calculate based on the specific application and what are the calculations that involved. So we will uh, I will be teaching you in the tutorial as well as in the lab, in the class, in the class. So we will see few examples which will be involving some calculation. Okay, so overall, so these two course outcome covering two program outcome. So program outcome one and program outcomes two, and the complexity level of the subject maximum is C4. So we have until C6. C6 is the design kind of, so it's a more tougher. So in the scale of C1 to C6, the subject is in the middle at C4. Okay, C4 normally will be involving some basic explanation that you need to give of on the principles and also theory, as well as some calculations. Okay, so the assessment for this subject, so the final exam covers 60%. Okay, so final exam usually we will have 4 to 5 questions. So usually will be 5 questions, and you need to answer all. And if you can't answer certain questions, so it will be tough for you. It will be tough for you to get better marks. So you need to practically understand everything that is taught. Okay, either you pay attention in the class and you understand all the principle. So if you don't understand, you listen back to the recording, or if you cannot attend the class and you need to rely on the online resources, so make sure you listen again and again. Okay, until you get a good understanding. And whatever information that we will be learning is not only limited to the lectures, but all these fundamentals and principles are available in the YouTubes, and also the other online materials and the books, reference book. So make sure put some effort. Okay, so I treat you all as an adult because you all are degree students. So you all not like other school student or diploma student, so which requires a lot of guidance. So I treat you all as an adult. So make sure you put some effort to learn, because understanding the whole uh, principles and also the theories are very important for the subject. So that's why previously the subject was in the third year, and a lot of people fail because they cannot understand. They are not putting, it's not that they cannot understand, they are not putting a lot of effort to learn. But we already reduced the complexity of the course, and we are putting this in the second year. Okay, so suppose you can understand better based on whatever things that I have seen, the outcome, the outline of the course. So it's understandable. So provided you put your effort as well. Okay. So that's why final exam, it carries most of it, 60% of the marks. So make sure at least you earn 50% of the marks from here. So 50 out of 60 minimum. So meaning you need to answer more in order to get more marks. Okay, so and continuous assessment for this subject. So we have three. So you will be having two assignments. Okay, so two assignments will be carrying 15 marks. So the assignments will not be easy because it's 7 marks. So it's not like a 5 marks or 3 marks assignment. So it's covering the first assignment will be covering 7 marks, and second assignment covering 8 marks. So make sure you put some effort to do. So no point carrying, uh, copying your friends, or copy from the internet or chat GPT or whatever tools that you are using. All these tools are good as a reference, but make sure you do yourself. So that is the maturity that you can show for the subject. Okay, so 15 marks is quite big. So unless you score that, so you will have a tough time scoring good grade as well. Okay, so put more effort. And I always see assignments students will send without a proper cover page, with uh, very sloppy job. So if I find any of these assignments like that, I will just throw away, or I will return back to you. So make sure assignments you prepare like a proper report. So because in Unima we do want to train. I'm not sure about other lecturers, but for this subject I expect that kind of level from you, because we are preparing you for the industry. So in industry you cannot do sloppy jobs. I believe you all know, right? So make sure you from now you start to practice, do a proper report. So make sure it is nicely presented with a cover page, with a proper writing. So don't use pencil. So pencil is only for drawing. So you as an engineer must be able to write with pen. Make sure it's clear, it's neat. So all that will be included in the marks as well. Okay, and we will have a quiz 1 and quiz 2. So the quiz that I will be conducting will be online, so I don't give a physical quiz. And online, so I'll be using the word wall application. Okay, so word wall will be like a game. Okay, so I believe most of you like to play game. So it will be just a fun game. At the same time, you will be answering questions as well. Okay, so you'll have two quiz which carry total 10 marks, quiz 1 and quiz 2. So make sure you score this as well. And one of the important part will be the midterm test, so which carries 15 marks. Okay, 15 marks normally will have two questions. So two questions, 7.5 marks and 7.5 marks. Um, So a midterm test will be a good gauge for me to understand your levels. So whether you can survive or not. If you cannot survive, after that, based on um, the recommendation from the program, so I will decide whether you should continue or not, whether you should drop the subject. So make sure from beginning you score, you understand everything and score the midterm test uh, with a good grade. Okay, so if you fail midterm test, so most probably the higher chance for you to fail the other parts as well. So better you just drop the subject and take some other time when you are okay with it. Okay. Okay, for the references, so we are using the materials from Chengal. Okay, so we're quite a good author. So if you can get these books, Fundamentals of Thermofluid Sciences, Thermodynamics and Engineering Approach, Heat and Mass Transfer. Okay, so e-transfer we are not really studying in this outline. We already removed from the syllabus, but mass transfer is there. Okay, so if you can get these books, it will be good for your reference. So if you can get online books also, it will be good as well for your reference. Okay, so the topic covered in this course, so we have 9 chapters. So today we will start with introduction to thermofluid. Okay, and we will have a basic concept of thermodynamics. Okay, and energy transfer, and first law of thermodynamics, second law of thermodynamics. Okay, so this will be covering the first part on the thermodynamics. Then we will enter to the fluid mechanics. So introduction to fluid mechanics, static fluid. Then we'll learn the dynamic fluids, fundamental fluid dynamics, and we will learn specifically on the Bernoulli's equation, okay, momentum analysis of flow system and internal flow. Okay, so these are the topics that will be covered. Total, we have 9 chapters for this course. Okay, so any questions so far? Okay, so if you have any questions, so please interrupt, or when Q&A time, you can ask. Don't after the class, whatever things that I already discussed in the lecture, your personal message me and ask. So personal message, so you better to ask in the class, during class, because if other people having the same questions, it will I'll give the answer to them as well. So if not, you have 30 plus people, so everyone asking one time, so I need to repeat the same answer so many times. So it will waste of energy, right? So better to ask during the class. Okay, so far, whatever things that I have shared, do you have any question? No question? Okay, if no questions, I will, before we go to the introduction to thermofluid, I'll just present to you the teaching plan. So this is the teaching plan for the subject. Okay, sorry, it's a 2 credit hour subject. Okay, so it's mostly on the fundamentals. Okay, so from the previous semester, so we have added more tutorial for the semester, and we will do more discussion on the problem solving, and also we will do interactive quiz and flip classrooms. I will explain later how we were going to do. Okay, so all these things I have covered, the synopsis and the course outcome. Okay, so we don't have a lab for the subject. Okay, so the teaching plan. So this is just a reference. So we will be changing in between. So in between we will have some changes, but generally we will try to follow this teaching plan. Okay, so mostly will be the delivery activities will be lectures. Okay, so we'll some chapters, if it's a bit long, we will divide into two. So we'll cover 2 weeks. Some chapters we will just finish in 1 week. Okay, so in betweens we will have tutorials. So we have 3 tutorials. So tutorial 1, tutorial 2, and also tutorial 3. And we will have assignment, quiz, and also test. So test I will be conducting after the mid-term semester break. So I believe you have other subjects as well, the midterm exam. So usually people will do before the midterm break, so that the lecturers can mark during the midterm break. But I just give some flexibility for you to study. So do revision during the midterm break. And when you come back on the 9th week, so we will have a test. Okay, so test will be face to face. Okay. Okay, so after the week 16, the revision week, we will have a final exam. So final exam usually will be 3 hours, covering 4 to 5 questions. Okay, so you can see, so all these assessments will be individual, so no sharing, so no group. Okay, so we will be having all the individual assessments. Assessment I already explained earlier. So this is the distribution of marks. Okay, distribution of marks for the final exam. Okay, so if you see the final exam question, so CO1 will be covering 20 marks and CO2 will be covering 40 marks. So meaning, so it will have some calculation questions as well, covering CO2. Okay, with the complexity of C4. Okay, so apart from that, I think the others I already explained. Okay, so any question? Okay, so if no questions, so we will enter to chapter number 1. Okay, so introduction to thermofluid. So today we will see a small part of the thermofluid. So what is actually thermofluid? So thermofluid is something that available since the creation of the earth. It's already available. So normally we know. So if you have taken physics in SPM, so I believe you are already exposed to the conservation of energy. So energy will be changing from one form to another form. So when the changes of form, so many thermofluid reactions will be happening, and because of that, so there will be a lot of changes in the earth. Okay, so that is what actually the thermofluid about. Okay, so introduction to thermal fluid science. So, or we call it as a thermal fluid. It's actually the same thing. So, thermal fluid science is actually the physical sciences that deal with energy and the transfer, transport, and also the conservation of energy. Okay, so energy can transfer from one point to another point. So in between the changes from point one to point two, you will have a transport similar like a bus. So you are taking a, or you want to move from one to point two. So let's say from Ulupau campus, you want to move to, you want to go to Kanga. So you need to have a transport unless you decide to walk. So you can walk. So even walking, you will have a lot of energies that will be conserved. So kinetic energy, potential energy. So if you are taking a public transport or you are taking a motorbike or car, so that is the form of transport. So you need a form of transport to move from one point to another point. So in this case, it will be energy, okay, and the conservation of energy. So the reactions that happening in between. So we will be studying throughout this subject. Okay, and the thermal fluid sciences are having three subcategories. So there are three subcategories. So first category will be thermodynamics. Okay, thermodynamics is something to do with the thermal. Okay, thermal means is the heat, and dynamics meaning the movement. Okay, so movement of the heat. Then you will have a heat transfer. Okay, specifically on the transferring of the heat, the temperatures, and also fluid mechanics. So fluid mechanics will be covering static fluid. Static fluid meaning the fluid that is not moving. So it's only being in one, like a dam, or so maybe a pond. So the water is not moving. Okay, the fluid is not moving, and dynamic fluid is like a river. So the water is moving from one point to another point. Okay, so if you see in the house, okay, maybe I always will encourage my student. So try to, maybe before this you didn't study the subject, so you just think all that thing is happening naturally. But from today onwards, try to evaluate around yourself, okay, in your surrounding. So maybe in the place that you are now, in your house, in your hostel. So what are the thermodynamics things that is happening? So what are the heat transfer things that is happening? what are the fluid mechanics things that is happening. So for example, in the house, you can see, so you have a solar panel on the roof. So it's dealing with the thermodynamics. Okay, so heat is transferring. So you'll have also heat transfer. Then you'll have a shower. Shower normally you'll have a water heater. So from the water heater you can get cold water as well as the hot water. So you'll have a heater inside. So you can have a heat transfer. Okay, and um, from the water tank. Okay, water tank. So you can have a pump or and also heat exchanger inside. So all these things are interconnected, so which we are using today in our daily life for our for us to do a lot of stuff. Okay, so when you have a hot water or cool water, so you can bathe. Okay, so you can do a lot of house chores. So a lot of things that can be done. Okay, and if you have a solar collectors, so you don't need to depend too much on the electricity. Okay, the electricity that is generated. So you can use the solar, especially in Malaysia, we will have a constant sun. Okay, constant sun, so you'll have lesser rain. So it will be a good thing for you to install a solar panel so that you don't need to waste too much of the electrical energy. So a lot of things you can investigate by your own. Okay, and I will give as a part of the assignment later. Okay, for you to do all this investigation. Okay, so try to think from now and try to evaluate what are the things that can be related to this subject. Okay, so application area of thermal fluid science. Okay, so we need to understand it's not limited to all these applications. So actually got a lot of things. Okay, so even in the house, the refrigerator or fridge, okay, we have boats in the on the sea. Okay, then we have aircraft and spacecraft. So we have power plants. Okay, we have a human body. Okay, cars. So cars are the very typical example because inside the car we have thermodynamics, we have fluid mechanics, and also heat transfer. So try to see which part is thermodynamic, which part is fluid mechanics, and also heat transfer. So you can do some investigation. Then we have wind turbines, maybe certain parts of Malaysia which are having a constant wind, so they can have they can use the wind turbine. Food processing. So even the food that we are eating is related to this subject. Okay, we will see later. Okay, the piping network in the industrial facility. Okay, so later you will do your industrial training. So if you come from the diploma background, you have underground the industrial training. So in the industry, you can see a lot of piping networks involved. So especially you are dealing with pneumatics, you are dealing with hydraulics. So you will have a lot of piping networks involved in this, related to thermal fluid. Okay, as I say, it's not limited to only this. A lot of things that are human made and as well as happening naturally. So are related to thermal fluid science. Okay, maybe now you can ask how this it is related to mechatronic engineering. So mechatronic engineering is related to thermal fluid science because we are dealing with mechanical part as well as the electrical part, electrical electronic control. So mechatronic engineers are easy to get job because we are covering a lot of things. So we are learning a lot of things. Okay, like mechanical engineers, mechanical engineering student, they only learn more on the mechanical side. Okay, electrical engineering student, they will learn more on the electrical side. But mechatronic engineers, we will be covering a lot of stuff. Okay, so mechanical part, electrical part, control part. Okay, electronic, electrical. So even now we have Internet of Things, we have artificial intelligence. So all these are falling under mechatronics. Okay. So since we are dealing with hardware and also software, so hardware part normally will be dealing with thermal fluid. So thermal fluid. So it is related to mechatronic engineering. So if you see in this picture, so we have a simple automation system, okay, and we have a pneumatic this hydraulic system. So hydraulic system, if you want to move the piston in and out, so you need to have a hydraulic power, so which coming from the hydraulic oil. So you need to supply. So the hydraulic oil must be moving from the tank to the piston. So that's a movement. So that's a transport involved. So you are using a pipe to transfer it. So it's all related to mechatronic engineering. Okay, so thermodynamics. So we will learn a little bit on the basics. Okay, so thermodynamics is actually the science of energy. Okay, so you can see, I believe you know kinetic energy, potential energy, and all the other types of energy. So thermodynamics is actually deal with the energy. Okay, science of energy. Okay, so the name thermodynamics stems from the Greek word therm. Therm means heat in Greek, and it's actually not dynamis, it's actually dunamis. So dunamis meaning power. Okay, so when the energy is moving from one form to another form, it is actually causing a power to happen, and the power can be used to move a lot of stuff. Okay, so energy is the ability to cause changes. Okay, so if you can see this picture here, so you have a rock on the cliff. Okay, when the rock is placed on top, it is actually having a potential energy, fully potential energy, because it's not moving, but it is standing at one point, even though it is experiencing the gravity, but since it's moving in one point, so the potential energy is 10 and no kinetic energy because it's not moving, so kinetic energy is zero. So this is fully on the potential energy. But once the rock started to fall, so because of the kinetic energy is moving downwards, so the potential energy of 10 is now converting to the kinetic energy. So even though the total is 10, here 10 plus 0 is 10. So here it is distributing. 7 plus 3 is 10. So the total energy is not changing, but it the energy is moving from potential energy to the kinetic energy. So it's moving to 7 to 3. Okay, so it started to have a kinetic energy. So that is what we call as a conservation of energy. So it's moving from one form to another form. So conservation of energy principle. So during the interaction, energy can change from one form to another, but the total amount of energy remain constant. So like in this case, total energy is 10 units, but the energy is from potential energy 10 units is changing to potential energy 7 unit, and another 3 is shifted to kinetic energy. Okay, so it means that the energy cannot be created or destroyed. Okay, so energy already available in the earth since the creation of the earth, but energy is moving from one point to one form to another form. So the energy cannot be created or destroyed. Okay, so we'll see a few example. Okay, the first law of thermodynamics. So first law of thermodynamics is actually the expression of the conservation of energy principle. So it's actually dealing with on the conservation of energy. Okay, the first law as the energy is a thermodynamic property. Okay, energy is actually something that can be measured. So that is what we call as a thermodynamic property. Okay, so let's see this person. So a sumo fighter. Okay, so let's say energy in. Okay, how normally you will take energy in. So only I am talking, right? So maybe as any one of you can answer. How normally you will take energy in your body? Anyone? Any bright student? Okay, anyone who know the answer? I think it's a simple question, right? How normally you will get energy?
Eating,
Yeah.
um, eating
Okay.
or
Okay. So you are
sleeping,
okay.
and rest.
Okay. So you are taking in food. Okay. So through food you are getting energy. Okay. So let's say you are getting when you are eating. Let's say you are eating MACD. So you are getting 5 unit of energy in. Okay, and you're doing workout. So let's say you are doing exercise or you are doing walking, long walking. So energy is a drain from your body. So the food that you took, so let's say you are doing only limited exercise and you only manage to burn 4 units of the energy. So initially you took 5 unit, you burn 4 unit. What will happen to the remaining 1 unit? So it will be stored in your body. So our body is using this principle, the thermofluid principle. So we are taking in fluid in even through food or drink. So you are taking in inside, but if you are not doing exercise, it will be stored as a fat in your body. Uh, so if you do exercise, the fat will be burned. It will be changing from fat. It will become energy for you to sustain, and through your sweat or other mechanism of the body, so the energy will be drained out. So that's why when you are doing going for gym, you are doing exercise, you are losing weight. So the losing weight is actually losing fat. The energy is stored in your body. Uh, at the same time, if you have a lot of fat, so you can be in a you can sustain longer in the cold country because your body when you are starving, you don't have food, so the fat will be converted into energy, okay, to make your body sustain. Okay, so that is actually a simple understanding, a simple example for you to understand how the first law of thermodynamic work. So the first law requires that the rate of energy transfer into a system be equal to the rate of increase of the energy of the system. Okay, so the first law is actually saying the rate of energy, meaning how fast the energy is conserved or changing from. Okay, is actually the rate of increase of the energy in that system. Okay, so if you are having a faster rate of energy in and you are having faster rate of energy out, so the energy will be converted faster. So meaning after you eat, after some time you straight away do exercise and burn that 5 unit of energy, so no energy will be stored in your body. So that is what actually first law is telling. Okay, so then we have a second law of thermodynamics. It asserts the energy as the quantity as well as quality as well as quantity, and actual processes occur in the direction of decreasing quality of energy. Okay, so thermodynamic is actually dealing with a lot of laws. So earlier we saw the first law. Okay, so this is a common question in the exam. Okay, so if you can take some note, so you can write it down. Okay, so what is normally the exam can ask, explain first law of thermodynamic, explain second law of thermodynamic. So all these questions are common. Okay, the second law of thermodynamic is actually saying that energy has a quality. So meaning even though it is calculated from one now, let's say like 5 units, 6 unit, 10 units, so that's the calculation. It has a quality as well. So meaning energy can be low quality or high quality, and it can have a gradient. So when you have high quality and low quality, you can have a gradient. And the actual process of thermodynamics is occurring in the direction of decreasing quality of energy. So I will explain to you what is decreasing quality of energy. So let's see this example. So you have a hot coffee. So normally you just took out from the microwave. So you have a hot coffee, 70 degrees. Okay, what will happen if you just place the cup of hot coffee on the table for 1 hour? Anyone can answer. What will happen to the hot coffee? 70 degrees. So let's say your environment is 20 degrees, as said here. What will happen after 30 minutes or 1 hour to the hot coffee? Anyone?
The temperature of hot coffee will become the same as cold environment.
Okay. So if you keep 30 minutes, maybe from 70 degrees, 70 degrees Celsius, so maybe it will become 50 degrees. Okay. So if you keep it longer, because your environment is 20 degrees, so let's say you are keeping it for 4 hours or 5 hours. After some time, from 70 degrees, it will be decreasing to 50, 60, 50, 40. And after once it reaches 20 degrees, will it go further down? Who can answer? So yeah, environment is 20. So will it go further to 10 degrees?
No, it will
No.
remain 20 degree.
Okay, so it will remain 20 degrees. So because your environment is 20 degrees, if your environment is 10 degrees, so it will go further until 10, but it will never go below the environmental or the ambient temperature. We call it as ambient temperature. So from this case, we know that the heat is transferred to the environment. Okay, so that is what we call. So your coffee cannot become hot by itself unless your environment is 100 degrees. So you put a hot coffee of 70 degrees, and because of the environment, so the environment can heat up. That's what is happening in the microwave. So you are increasing the temperature of the microwave to 100 degrees. So the heat will be going inside. So your coffee from 20 degrees it can become 100 degrees. So but it requires a external mechanism, but it cannot happen naturally. So it cannot happen naturally. So that is what the second law of thermodynamics is saying. So it is actually happening in the decreasing quality of energy, meaning 70 can become 20, but 20 cannot become 70 by itself. It cannot happen naturally. Okay. Okay, so that's on the thermodynamics. So we'll cover a little bit on the fluid mechanics. Okay, fluid mechanics is the science that deals with the behavior of fluid at rest. Okay, if the fluid at rest, so meaning the water is not moving, we call it as a fluid static. Okay, okay. So one understanding that I need to give: fluid is not the liquid. Okay, fluid is not liquid. Fluid is actually liquid as well as the air. Air also is considered, okay, in Malay we call udara, right? So the ambient air, so or whatever generated air, so everything are considered liquid as well. So fluid, when I'm saying fluid, it is actually referring to a liquid and also air. Okay, so you need to get. So normally we will have a misconception that fluid means is water, is a liquid. It's not. A fluid involve air as well as water. Okay, so fluid mechanics is dealing with a static fluid. Okay, even air can be static. Okay, so and if it's in motion, we call it as a fluid dynamics. Okay, dynamics meaning is moving, and the interaction of fluid with the solids and other fluids at the boundaries. So that is the definition of fluid mechanics. Okay, fluid. Okay, so it's already told here. Okay, fluid is actually a substance in the liquid or gas. So if it's in liquid like water or it's in the gas, so it can be in either phase. So it is considered as a fluid. Okay, a solid can resist and apply shear stress by deforming, where a fluid deform continuously under the influence of shear stress, no matter how small. Okay, meaning you have a solid in between two plates. So if you move, the bottom plate is not moving and the top plate is moving, so it will experience a shear stress. Shear stress meaning is a stress in the same direction of the movement. Okay, so that is what is actually saying. We will be studying all this. Today is just an introduction. We will be studying more on the fluid mechanics and all the shear stress in that chapters. Okay, so a lot of explanation to give. Okay, fluid mechanics itself is also divided into several categories. So we can have a incompressible, so meaning you cannot compress a certain fluid. Okay, so like water, so you only can compress for certain range. After some time, we cannot compress. But gas, naturally, you can compress a bit more. Okay, and then we have hydrodynamic, a term called hydrodynamics. So meaning the movement of water or liquid. Okay, so that is what we are using in the hydraulics. Okay, so this later part you will be learning about pneumatics and hydraulics. So pneumatics are dealing with compressed air, and hydraulics will be with hydraulic oil. So oil is actually a form of liquid. Uh, so you can study that uh, in the flow of pipes and also open channel because it's moving from one point to another point. Then we have gas dynamics. Gas dynamics meaning the movement of air. So deals with flow of fluid, okay, or air that undergoes significant density. So aerodynamics, okay, so I think you are familiar with this. So aerodynamics is something to do with flow of gas, okay, over a body. Okay, so normally if the car is bulky, so in front is not aerodynamic, so it cannot, it will slow down when it is facing the wind. But when the body is aerodynamic, so that's why the aircraft will be sharp in front, because it want to reduce the resistance when it's fly. So similar in the car. And we also have other terms like meteorology, oceanology, and hydrology. So all these are dealing with naturally occurring flows. Okay, in the ocean, in the river. So it's happening something that is happening naturally. Okay, then we have heat transfer. So heat transfer, I think I already explained earlier, a form of energy that is transferred due to temperature difference. Okay, so but we are not covering this in this course, but I think I already gave enough explanation on this. Okay, and all these calculations related to conservation of energy. So we are dealing with dimensions and units. Okay, so dimensions and units. So like if it's related to length, we have a SI unit of meter. So mass is kilogram, and temperature we have Kelvin. So amount of matter we call F mole. So all these are coming with the dimensions and also units. Okay, so units are m, kg, s, Kelvin, ampere. So all that are unit. So we also have derivative units. So we call as a secondary dimension or combination of a few of these. So you can generate another when you apply to a certain formula, you can generate some other equation. So that we call as a secondary dimension. So then we also have prefixes that we usually will use in the calculators in a calculation. So I think we only know until Terra usually because of our data size. So, but we have more. Okay, we have more. Okay, all these are used in the calculation. So we are used to SI calculation. Okay, so like we are using meter, but we also have an English system like pound, so pound, and also um, like, other types of dimensions. Okay, so point to ponder. Okay, so maybe you can. I will give this lecture notes. I will create a Google Classroom later, and I will put all the lecture notes and the materials, the teaching plan, everything I will put there. So make sure after this I will create and I will give you the Google Classroom. So try to download the lecture note, okay, for today, and try to answer this. Okay, try to answer this. So it's just some situations that I give for you to learn and for you to think. Okay, so summary today we have seen about the course outcome course outline for the subject, and we have seen the introduction to thermal fluid science. So we have understood what is thermodynamics, heat transfer, fluid mechanics, and the importance of dimensions and units. Okay, so all this for the introduction. Okay, so after this, in chapter 2 onwards until chapter 9, we will be looking more in details on this. Okay, so 11:59. Any question? Any question?
No, doctor.
Okay, so if you have no questions, I think we will dismiss the class. So we will discuss in the WhatsApp group on the lecture time, 2 hours of lecture time that we will finalize. Okay, so thank you so much. We will meet next week.
Thanks,
Thank
Doctor.
you, doctor.